Hey guys, hope you're doing well. Welcome again to the complete video series of CCNA 200-125 Video 3. Today we are going to learn some of the types of network media that we might be using to interconnect components. Let's get started with the very first network media type, which is coaxial cable. Coaxial cable was seen a lot in the early days than we see it today. It was quite famous in the early 90s. It was used in 10x2 and 10x5 Ethernet networks. What you see in the screen is called a T-connector. The cable that comes from our PC, we would take it and push it into the T-connector to lock it in. The coaxial cable used in our networks has an impedance of 50 ohms. The next network media type that we are going to learn about is a twisted pair cable. In this cable, there are pairs of cables that are twisted together. These twists are there to protect the wire from electromagnetic interference, that is EMI. If you get to see the wire, you will notice that there are different number of twists on each cable pair per inch. If these twists are not tight enough, we become an antenna and start radiating. In this case, these radiations can start interfering with other devices. There are two types of twisted pair cables, shielded and unshielded. Shielded pairs have a metallic cover which gives them an extra immunity from electromagnetic interference. But as they were very expensive, the unshielded twisted pair grew in popularity, and that is what we see today. This is the most common type of media that we see today. The different colors of the cables are the standards which tell us which cable should be connected to which pin in an RJ45 connector. These standards were defined by the TIA in 1991 and were updated in 2001. There are different categories of the twisted pair cables. Let's talk about them a bit. First we have the category 3. Category 3 was often used in telephones in PBX, that is private branch exchange installations. When Ethernet started to catch on with unshielded twisted pair, the existing telephone line was used to connect to a network. 10 base T devices were used which gave 10 megabits per second. After that, Category 5 came in use for the fast Ethernet. It gave us a speed of 100 megabits per second. Nowadays, it is common to get a network interface card that runs at 1 gigabit per second, and Category 5E can give you speed of 1 gigabit per second. Also, Category 6 can give you speed of 1 gigabit per second, but Category 6 is a bit better than Category 5E. Category 6 cable has a thicker insulation. And finally, we have the Category 6A cable, wherein the A stands for augmented. It supports twice as many frequencies as Category 6. It gives us a speed of 10 gigabits per second. If you have seen an RJ45 connector, you might have noticed that there are 8 pins in it. Ethernet by default uses only 4 of those pins, that is 1, 2, 3 and 6. There is pair of pins to transmit data and a pair of pins to receive data. We might run into an issue if we connect two switches via a straight through cable, and by straight through cable I mean pin 1 of RJ45 is connected to pin 1 of other RJ45 connector and so on. That is, the pins match up. In this case, both switches want to transmit and receive data with the same pins, which might cause a problem. So, we might need to have a crossover cable. This cable takes pins 1 and 2 and connects to the pins 3 and 6 at the far end. In this way, the transmit pair on one side of the cable gets connected to the receive pair on the other side of the cable. However, there is a feature called MDIX, Media Dependent Interface Crossover. If a switch port is configured for MDIX, then it knows which pair should be used to transmit or receive data, which means we can connect the switches with a straight through cable. MDIX recognizes straight through cable and if needed converts transmit pair to receive pair and vice versa. It can dynamically change the roles of the pins depending on what it detects. The third and the last network media which we are going to learn about is fiber optics or optical fiber. Optical fiber is not going to represent data as electrical pulses but as pulses of light. The absence or the presence of light is going to represent if we are going to send a binary 0 or a binary 1. And since we are using light, this gets completely rid of issue of electromagnetic interference. Fiber optic cables can cover long distances than unshielded twisted pair. There are two types of fiber optic cables. We have multimode fiber, that is MMF, and we have single mode fiber, that is SMF. What happens in a fiber optic cable is refraction, which causes the light to bend. In a fiber optic cable, we have inner surface called a core and an outer surface called as cladding. There are two such strands in a fiber optic cable. One is for transmission and the other is for reception. The index of refraction are so different in core and cladding that the light bends on itself and is not able to escape from the core. In a multimode fiber, the diameter of the core is so large that the light can enter this core in different angles. So we can have issue with this if the distance is greater than 2 kilometers. If one light enters the core at a steeper angle than the other, then it is possible that the bits get out of order as the light at the steeper angle will take more time to reach the far end. A term for this is called as multimode delay distortion. In a single mode fiber, the core of the cable is so small that it allows only one light to pass through it. Single mode fiber is costlier than the multimode fiber. In single mode fiber, as we do not have multimode delay distortion, we can achieve much more greater distance, that is maybe 40 kilometers for an example. Here we come to an end for the network media. In the next video, we are going to classify the networks according to the geography. If you like this video, please press the like button below and share it with your friends. Also, don't forget to subscribe to our channel, that is Impact Tube.